Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Grace Jensen, who will be presenting on the topic of boosting developer productivity with open source Java technologies. If you have any questions for Grace as we move through today's presentation, feel free to ask them in the chat or click on the Ask a Questions tab. Without any further delay, Grace, over to you.
Thanks so much. Really appreciate the kind introduction. It's great to join you all, and thank you for joining this Jakarta Tech Talk, especially to those who are joining from what must be intense heat in Italy. I can see in the chat we've got someone from Rome here, so thank you for staying inside, hopefully with some aircon or at least a fan. I hope you're doing well over there. But yeah, today I'm going to be talking about sort of boosting developer productivity with open source Java technologies. For anyone who doesn't know me, my name is Grace Jansen, and I'm a developer advocate at IBM based in the UK. I mostly focus on things like cloud native Java technologies. I've done a bit of reactive in the past. And then before I was into software development, I was actually completing a biology degree specializing in fish. So if anyone wants to chat about that later, I'd be happy to. But as has been said already, if you have any questions, then please do put them in the chat. I will be looking at them afterwards, and I will leave some time for those as well. So without further ado, oh, there we go. Sorry, seems that I lost my screen for a second there. Apologies.
That's okay. No worries at all.
There we go. We're back. Perfect. Fantastic. Okay, so we'll get started. So the first thing that I want us to consider really when we're looking at sort of why we care about sort of boosting our productivity, especially when it comes to sort of developing applications that are designed for cloud native, is really sort of why we care about this. Why are we bothered about trying to create effective cloud native applications and do so in a very productive manner whilst we're making them for the cloud? And really that all comes down, the way that I like to boil it down is through this, which hopefully you've seen Toy Story and you'll be familiar with this screen, which is this excitement that we get as developers, this, ooh, the cloud. We get excited as developers because we want to be able to utilize the infrastructure, the innovation that it offers, the advantages, things like portability, flexibility, and innovation, as I said. So how do we go about actually achieving this? By creating sort of and utilizing tools from hopefully open source sources so that we can really utilize innovation from the collaborative community to be able to effectively make cloud native applications. Well, when we're actually designing and developing them, it doesn't always feel like this feeling. From afar, it can look really exciting, but actually when we start getting into the depths of developing cloud native apps, it can often feel a bit more like this. I mean, it's a little dramatic here. You're probably not quite getting to this level, hopefully, but it can feel a little bit more like this. You're sitting there, it's frustrating. Sometimes it can take ages to get just the simplest of tasks done. And so it's important that we utilize these open source tools to be able to make this a lot easier, a lot more efficient and effective, and to really enable developer productivity. So what are we trying to achieve with this? Well, the first thing we need to consider is sort of what we're trying to do as developers to then analyze the tools that can help. And what we're doing as developers has really rapidly evolved over the last few years even. So it involves not just creating a new project. Obviously, there's adding and editing code. We've got to consider things like how we're going to build, package, and run that code. Obviously, we're all best practice developers, so we're testing our code and following best practices that way. So we've got to test our code. We've got to actually write those tests. And often now we're looking into sort of expanding that role to cover more of the DevOps side of things. So how are we deploying it, looking at the operations side, although we're not going to focus too much on that in this presentation just because of time restraints. We're mostly going to focus on the first few parts of sort of what a developer is doing on a day-to-day basis and what tools can help. So I took that list and sort of turned it into a diagram, really sort of to visualize that inner dev loop that we often go through when it comes to creating our applications. And most of these different stages happen within an IDE or an editor, and actually that can play a big part in how we can enable effective tooling for us to be able to make these stages much easier using open source tools and technologies. So how? This is what we're all here for, right? We know we want to create applications. We know we want to be productive as developers, but how do we achieve that, and what open source tools and technologies can help? I'm going to spend just a few slides here introducing some of the open source projects and technologies and specifications that can help, and then we'll dive directly into the tools in a minute. So the first of these is OpenLiberty that I want to introduce. I'm going to be demoing many of these tools, and the demos that I use are going to be using OpenLiberty. So I want to cover this a little bit for anyone who's not come across it. OpenLiberty is a cloud-native runtime that's really designed for the cloud. We've got a website, and on the website, we've got a bunch of different guides. So a lot of the demos I'm running today are from our guides. So if you fancy having a go with this yourself, then you can head on over to this website and have a go with these guides yourself. They take about 15 to 20 minutes, and they're quite fun and interactive. So a great way to get hands-on with these technologies and tools. OpenLiberty can be a fantastic tool to use to make cloud-native applications, really because it allows you as developers to focus on the code instead of having to worry about integration with the open source technologies and specifications. It enables you to have really fast and iterative changes through some of its tools and features. It enables that really effective testing. It's ready for containers, and it's a really nice modular runtime. So really, you just add what you need, making that memory footprint nice and small so you can be effective in terms of cost in the cloud while still having that high throughput. So a really great tool to make use of. So that's what we're going to be utilizing today. However, because this is all open source, many of these are based on open source community standards and specifications. So if you aren't using OpenLiberty and you're using something else, you should still be able to utilize many of these tools with alternative runtimes that still support those open source specifications. So the next project I wanted to just briefly cover is MicroProfile. So if you've not come across MicroProfile, I would definitely recommend checking out this specification. It is a cloud native specification really designed for applications that are using either Jakarta EE, hopefully, or if you're using Java EE, then it's designed for you to sort of add capabilities and APIs and behaviors that enable you to make effective cloud-native microservice-based applications. So you can see they're generally grouped into segments. So you've got the core APIs at the bottom here. And for those keen-eyed who are already familiar with Jakarta, you'll notice that some of those are shared with the Jakarta EE specification, which we'll go over in a minute. We've also got the integration layer and then the observability layer on top. And many of these APIs can be really helpful when it comes to the cloud, and we'll be utilizing some of MicroProfile's features and tools throughout this demonstration. Now, the nice thing with this is because it's an open source specification, there are loads of different compatible implementations that you can make use of. So this is where we're really starting to get into, that portability, flexibility that we really want to achieve in the cloud. As you can see here, depending on the version you want to use, there's lots of different compatible implementations you can make use of. The latest release that just came out this year is version 6, and that introduces some new APIs and capabilities, but you can see there's lots of other versions and other runtimes that offer it as well. And then the last final one, just to briefly intro, is of course Jakarta EE. This is a Jakarta EE Tech Talk. I could not introduce this. Many of you, given that you're already watching this Tech Talk, are probably familiar with this. If you're not, and it's your first time joining a Tech Talk, then welcome. This is essentially the evolution into the open source of Java EE. And what it allows is a very similar set of sort of APIs and capabilities to enable you to effectively make cloud native Java applications. There are lots of different specifications offered, and it really depends on your what capabilities you need and your application as to which profile you might need, whether that's just the core profile or whether you're going all the way up to web profile. Lots of different capabilities offered at each of those sort of various different packages, I guess you'd call it. So we're going to be utilizing OpenLiberty, MicroProfile, and Jakarta EE throughout this presentation as we look at the different tools that can help with developer productivity. So hopefully, now that we quickly run through those, you've got a basic understanding of what open source we'll be using, and now we'll delve into the tools themselves. If you haven't come across any of those open source specs or tools, and you're interested in finding out more, I do have a link slide at the very end of my presentation, and I will be sharing the presentation as well. So as well as the links that are scattered throughout my presentation, you should be able to follow those links to sort of do any follow-up investigation you want to do, or just try stuff out after this session. But again, if you have any questions on that, feel free to put them on the chat. I am kind of trying to monitor as we go along, and I will also, get around to sort of trying to post any links that you specifically asked for there at the end. So going back to our development cycle, now that we've seen the open source specs and technologies, what tools can we use to actually help? So in this, I'm going to be going through each of these separate stages within this inner dev loop and looking at some of the projects and technologies that can help. So the first one we're going to start with is really sort of where we start off with as developers, which is, okay, I want to create a project. I want to create an application. Where do I start? So looking at that create phase, one of the fantastic tools that you can utilize is starter projects. Now, for some of you, you might be developers who've already made use of starter projects before, or perhaps you've already got templated applications or skeletons that you can make use of. But especially for anyone new to your organization, or if you're new to Microprofile or Jakarta EE, then starters can be a fantastic place to start off with to be able to really quickly and effectively get up to speed in terms of just creating that skeleton application in literally about 10 minutes. There's different starter projects depending on sort of what technology you're focusing on or what technology you already know you want to use. So one example is the Microprofile starter project. So for this, it essentially, as I said, gives you that skeleton or that template for a Microprofile application. The nice thing with this particular starter is that actually you can either use the website itself, which is start.microprofile.io, and that takes you to this screenshot that I have here where you've got essentially drop-down options in a GUI where you can select various different variables and configuration properties. So for example, your artifact ID, which Microprofile version you want to use, which build tool, and which runtime you want to use. It's important to remember with Jakarta EE and Microprofile, they are specifications. So you will need an implementation to actually be able to make use of them. So do bear that in mind. So you can either use that website or you can use some of the IDE plugins that are available. So there's VS Code as an extension, or you can use the IntelliJ plugin. So that's quite nice, and we'll demo one of those later in a minute to really show how you don't even have to leave your IDE to make use of tools like this to get up and running really quickly in creating projects. If you want to use Jakarta EE and you know that's definitely a technology you want to make use of, you can also use the Jakarta EE starter project, and they have their own website with a very similar sort of domain, which is start.jakarta.ee. Or if you already know the runtime you want to use, you can also use runtime specific generators or starter projects. So for OpenLiberty, for example, we have start.openliberty.io with a very similar looking GUI where you can choose things like your Jakarta EE version, your Microprofile version, your build tool, etc., Java version, all of those kind of things. So these can be really helpful in getting up and running really quickly and helping with that create stage. Okay, so now that we've got the basic template of an application and we can start utilizing it, what about actually being able to build that application? Because at some point we're going to need to build to be able to actually utilize this application. And one of the tools that you can make use of is dev mode. So dev mode is an OpenLiberty specific feature. However, there are various different sort of comparative alternatives in the various different runtimes. You might have heard of, for example, hot reload in Quarkus. So really check the runtime, but many runtimes offer very similar capabilities in this regard. For OpenLiberty, it's called dev mode. And that really is all about sort of being in development mode. So enabling you as developers to be able to effectively and iteratively see your code changes in an agile manner. So being able to really create applications and be able to see sort of cause and effect as you make code changes, to be able to see what that effect has within your application once it's deployed and built. So what this allows you to do is really what's happening in dev mode is the server is essentially monitoring your application. And every time you make changes to a particular class, for example, and you save, it's able to automatically recognize that that class, just that one individual class in this case, has been edited, and it's able to rebuild and redeploy that particular class without having to tear down your whole application and bring it back up again. So this means that you save a lot of time in terms of waiting to be able to see those code changes. It's really useful in terms of being able to continuously have sort of hot testing. And the nice thing is it also comes with container support. So in order to utilize dev mode, you can use various different commands. So in this case, the commands I've got here are for Maven, just because in the majority of our demos, we tend to use Maven, but you can also use Gradle, or if you really want to, Ant, it's up to you. But for dev mode, we've got Maven and Gradle, and all the command is just instead of Liberty Run, you'll be using Liberty Dev. And if you want to use it with container support, you'll be using Liberty Dev C. And you can see here, I've got sort of a sample of essentially the fact that we've included Liberty tools to be able to make use of this. It's really effective when we're looking at sort of debugging our code effectively and being able to see those code changes as they happen. So that's sort of the build side of things. If your runtime doesn't offer a similar sort of feature or technology for this, there are open source tools and technologies that you can utilize, like Watch and Deploy, WAD. So WAD is a project that was created by Adam Bean, and you can find it on GitHub. And it essentially allows you to achieve very similar capabilities if your runtime doesn't offer it. So if you're using a runtime that doesn't, then check out Watch and Deploy as an alternative. Okay, so that's the build side of things. Now we want to get into the nitty-gritty of, okay, but my application requires my own code. That's why we're developers, right? Like, that's what we create, that functionality within our applications. So how do you achieve that with greater developer productivity? So the first thing is to really make sure that we have effective IDE or editor integrations that can enable us to be able to be more effective and more productive developers. Now, we're developers, and I think it's fair to say that we're quite an opinionated bunch. So your favorite IDE might not be my favorite IDE or anyone else's on this session. So I've tried throughout my demos here to use a variety of different IDEs to really show that this is applicable across various different IDEs and editors. But you might be using some of the more popular ones, like, for example, Eclipse, IntelliJ, VS Code, NetBeans, whatever it might be, making sure that when we're in this editing stage of that dev loop, we have the effective plugins and extensions installed. And especially if you have newer developers or, let's say, less experienced developers on your team, ensuring that they have the most effective extensions and plugins, because it's not always something we know to look for when it comes to someone who's new to a project or new to a technology or just new to software engineering. So make sure you're sort of being that team lead and ensuring they have the correct ones installed and ones that will make them more productive and effective. And this can really help with things like runtime lifecycle management. And you can also use custom runtime plugins as well if you have those available. For example, there's an OpenLiberty one that I'll show. So it can be really easy to be able to install these, and it literally can save so much time and make it just your coding and editing your coding so much more effective. This is just a brief demo where I'm showing some of the microprofile extensions that you can have. This is in Visual Studio Code as an example. Really easy to install them, and they offer fantastic help and capabilities in terms of auto-completion, corrections. This is the Liberty Tools plugin that I mentioned. If you want runtime-specific plugins, those are available as well. In this case, we're using the Liberty one. As I mentioned before, you can utilize those APIs and extensions to be able to utilize the starter project for microprofile. So in this case, within Visual Studio Code, I'm actually utilizing those extensions and plugins to use the starter project in my IDE. So I don't even have to leave my IDE to get this skeleton up and ready. So you can see here, it's just asking me essentially the same drop-down questions that's in that GUI that I had a screenshot of. So what version of microprofile do I want to use? What runtime? What JavaE do I want to use? What build tool? And then it's going to ask me which microprofile APIs I want. Again, this is all plug and play. It's trying to make sure your application is as small as possible to be as effective in the cloud as possible. So only selecting the APIs you really need to make that memory footprint as efficient as possible. And then all I'm doing here is essentially making sure I have the correct place to store it. And here you go. Within just a couple of minutes in my IDE, I've been able to create a skeleton of sort of utilizing Liberty, as you can see there in my build.gradle file. I've got the microprofile and the version that I want. So in this case, it's 4.1. And you can see that I've been able to create this skeleton for an application that I can then just go ahead and start adding my own functionality to in a really quick and efficient and productive manner. You can see in the bottom left-hand corner here, we also have the Liberty dashboard, and that's part of that Liberty Tools plugin that I showed, where I can actually sort of analyze and start up REST clients that are within my application, all from within my IDE. So making it really efficient here rather than having to switch between terminal and like my browser, for example, to be able to achieve all of this. So really helping with productivity there. Another example here is this is in Eclipse. So again, I'm trying to be diverse here with my IDEs to show, hopefully, to all of you that this is applicable no matter which IDE or editor you're using. So in this, we're using the Liberty Tools plugin this time for Eclipse. And here I'm showing the Liberty config language server that comes as part of the Liberty Tools. The nice thing with this is that it enables sort of Liberty config language server features are available for things like server.env, bootstrap properties files, and server.xml, and any XML files really that are referenced in elements of that server.xml. And you can see here, if I hover over, I get more in-depth information about what each of those features is enabling. This also allows things like auto-completion for Liberty properties and values, and for variables, completion of Liberty XML configs, and as I just showed, being able to hover over properties and variables and understand a bit more about it, and gain diagnostics on those Liberty properties and variables. So it can really help in terms of being able to have a deeper understanding of what's going on in my code, and get help for that if I have anything that's perhaps wrong or incorrect, and being able to utilize that completion. Now, sort of building on from this is from the Liberty Tools, and that was one of the plugins and extensions I showed. We can also utilize alternative language servers for some of those open source tools and technologies I showed earlier. So in this case, we're still in that edit phase. We've moved on now from just having an extension on IDE, and now we're looking at coding assistance. So how can I get help if I'm specifically using MicroProfile, for example, inside my editor or IDE? And there is a project called Eclipse LSP for MP. It's a mouthful. We love acronyms in tech. It's basically language server for MicroProfile. And this is at the moment is an incubator project at the Eclipse Foundation. But really what it allows us to do is very similar properties or features and behaviors to what I just showed in the Liberty Tools, where we can have things like help in terms of completion of code when it comes to MicroProfile, and also things like understanding by having that hover over feature, but this time specifically for MicroProfile and not just for the runtime. The nice thing is that there's actually something called Tools for MicroProfile that was developed by Red Hat, which allows us to be able to use this inside VS Code as an extension. And there's also a similar set of tools. So we also have language server for Jakarta EE if you're looking at specific help for Jakarta EE. Again, this is another incubator project under the Eclipse Foundation, and we are looking for help in developing this. So if you fancy having a go with it, then please do help contribute using the links that I've included in these slides here. But to give you an idea of what this looks like, here I've got an IntelliJ demo where I'm showing this language support for MicroProfile. Also note here, I'm also demoing the use of Liberty running in dev mode. So that's that hot reload function that I was talking about, where it's analyzing our application and sort of watching for any class changes, and when I'm saving that, redeploying or rebuilding that particular class, which I sort of talked about a bit earlier. And you can see it mentioned in my terminal here in the bottom of my IDE. You can see task Liberty dev. So that's how I'm executing it. So what I'm doing here is I'm creating a cafe controller class. And in that class, I'm using the @REST client annotation from MicroProfile REST client, which was one of those APIs that was offered through this specification. So as I start to sort of create this, I'm going to start getting some warnings. You can see here, I've already got a warning, and my quick fix was that I hadn't imported path. So it just gave me that quick fix to be able to import it. Now, when I try and use @REST client annotation, I've got a warning because I've used this incorrectly. What I need is a CDI bean because I need to inject it. So I need the @inject annotation if I'm going to make use of @REST client due to that sort of need to be able to inject it as a CDI bean. So you can see by utilizing these language servers, I can really get help as I edit and develop my application and add in that functionality if I do anything wrong, auto-completion, understanding code in more depth. So really it can help me be more productive, especially more productive for newer developers who are less familiar with these specifications and with these projects. So definitely check out the language servers especially, but also any applicable open source based IDEs, extensions and plugins, because they can really help an awful lot. Okay, still in the edit phase, now I want to check out, okay, I can see that I can get help in terms of sort of help with the specific tools and technologies I'm using, and also utilizing those extensions and plugins. But what if I need help actually generating boilerplate code? How do I do that utilizing open source tools and technologies? Well, actually, we can make use of things like microprofile REST client. We can be able to create those from OpenAPI docs. And we can do that in two different ways. We can do that either using things like the CLI via OpenAPI tools, or we can use the VS Code extension. So another extension we can make use of here. We can also generate JAX-RS stubs, again, using OpenAPI tools. If you've not come across OpenAPI, then definitely go check it out. We actually have a guide on that on our OpenLiberty website. So have a play around with that. Get familiar with how OpenAPI code is generated and how that can help to be able to create boilerplate code like this. So let's have a look at this in action in terms of how this actually helps with our productivity. So in this, I've got, again, this is an IntelliJ in this one. What I'm trying to create is I'm trying to build a REST client using that microprofile REST client generator. So we're using the generator here. My aim is to create a REST client that's going to connect into our REST service using that generator. Now, the first stage in this is that obviously, in order to use this, we need to parse it, the OpenAPI document, because that's how the microprofile REST client is generated. So the first thing it's going to ask me to do here is it's going to ask me to, there we go, I've got the plugin. So I'm utilizing that plugin to be able to create it. So I'm going to give it essentially where my OpenAPI document is. So I'm going to copy over that, paste it in here. And then, so I'm passing it the OpenAPI document from the REST service, which is our hello controller class. I'm going to click generate, and now it's generating it for me, and verify the package name. So this creates a whole REST client interface based off that OpenAPI document. So you can see here, we've got the API folder, and within that, the models folder. And the models folder was generated to work with the drink object, which is based off the drink schema in the OpenAPI document. So you can see here, we've got public class drink, and that's essentially all come from that OpenAPI document that was generated from my REST class. So as we're going into the APIs folder, you can also see, there we go, the drink one that I'm highlighting here. And you can see it in the OpenAPI document here in my schemas. So it's come directly from that. In the API folder, you can see I've got some exceptions here and the default API class as well. And this is really the bulk of what we need to be able to get this working. This is a whole REST client interface. We can see it has all the endpoints with the right post or get annotations that we need from our REST service, for example. So all we need to do to make use of this default API class in order to control our REST service. So in order to do that, we need to add a base URI that we want to use for this. You can see up at the top here, we're just going to add base URI. And we're going to point it at the base URI of the REST service for this app, which you can see in my OpenAPI document here. So we're just going to copy and paste that in, make sure we're saving. And as you can see at the bottom here in my terminal, Liberty is automatically recompiling based on that. So I don't need to tear down my application and restart it because I'm using dev mode. So it's as simple as that. In literally, what was it, about 4 minutes, we were able to get a REST client using the microprofile generator to be able to actually make use of the REST service within our application, all using boilerplate code with just a few added additions to be able to sort of connect it all together. So really, really helpful in terms of being efficient and productive when it comes to using REST within our applications. So a really great tool. Now, another one is sort of we're moving past the edit phase here. So we've gone from create to build to edit, and now we're on to test. So when it comes to actually testing our application, because obviously we're all best practice developers and we are testing all our application and making sure that it works as expected. When it comes to testing, we obviously have the usual suspects that many of us are probably already making use of. So things like, for example, a JUnit, we might be using our Quillian, whether it be contract testing with Pact, whatever it might be, there are obviously the usual suspects. Now, they can be really useful in terms of having sort of unit testing and a little bit of sort of integration testing there. But when it comes to testing, what we really want to achieve is that dev prod parity that's talked about so much when it comes to cloud native applications and methodologies, like, for example, the 12-factor and the 15-factor app methodology that really highlight the importance of having that dev prod parity or that environmental parity, making sure that the various different environments that we're deploying our application into are as similar as possible, so we can really mitigate the risk of potential errors coming up that we didn't spot in development, for example, that occur and crop up in production that mean that our application isn't responsive or isn't performing as we were expecting. So in order to achieve that similarity, that parity, when it comes to developing cloud native applications, it makes sense that when we're testing, we want to be using the same environment, the same sort of components, the same architecture, to be able to make sure our testing is as close to production as possible. In order to do that, usually what this means is leveraging containers, because we're deploying naturally into containers when it comes to the cloud. We want to be testing in containers to be able to ensure that we're spotting those errors and dealing with them. And we can use various different technologies and open source tools for this, one of which is test containers or microshed testing. Microshed testing is essentially an implementation of test containers. So under the covers, they're sort of doing the same thing. Test containers allows us to leverage containers to effectively test our applications. The way it works is a little bit like this. It really focuses on sort of those integration tests. So within test containers, you can still make use of JUnit and those kind of frameworks to have the unit tests, but really this is enabling us to have integration tests in a much more similar manner to our production environments. So really testing in the same way. And the nice thing is that because this is all open source again, and it's a standard, these tests are then portable to any compatible implementation. So whether that be Liberty or Wildfly or Payara or Tomei, whatever it may, or Quarkus, whatever it might be, the nice thing is that we're able to sort of port those tests no matter which runtime we're using. And you can see an example here in my diagrams that I've got up on the screen. So in our dev test environment, what it looks like is essentially the integration tests are directly taking the place of those end users to be able to test our application, which is running in a container that then might be leveraging other backing services, for example, which might be in separate containers, like, for example, a MongoDB database. So really allowing us to get as close to production in terms of the infrastructure and the architecture as possible. The nice thing is that essentially, again, you're getting as close as possible. And what it should allow is not only are these tests compatible to any sort of compatible implementation, it should also allow you to get the same results as someone else who's testing your application in the same way. Because you're using containers, it should mean that you don't get the usual problem of, well, it works on my machine. It shouldn't work on any machine if it doesn't work, because you're using containers and those environments should be the same. So you should be able to replicate any errors or issues you're having when it comes to tests. So really helpful, especially when you're working with, say, remote teams, for example, or even teams that are creating other parts of your applications that might not work directly with you. So having a look at how this works, we've got a demo here. Now, this is actually using one of the guides that I mentioned that you can check out. I do have links to them at the end, so I will show you that. But we have about, I think it's like 56 different guides going through loads of different open source technologies. So please do check them out. We are very proud of them, so please use them. They're free, and it's mostly based on open source, so you should be able to have a go with it yourself. So taking a look at this, in this particular example, I'm using microshed testing. However, we also have an example with test containers directly if you'd rather use that. In this case, I'm doing it locally. However, you can do it in our cloud native environment, which I'll show you later as well. So in this, I'm going to utilize Visual Studio Code for this. And what I'm doing is basically taking an application that was previously just using, say, unit tests, didn't have anything particularly special, and I'm going to be able to integrate or enable test containers in it. So the first thing I need to do is make sure I've got the right project. So I've just cloned that down from GitHub. All our applications and all of our guides are available freely and open source on GitHub, so you can check them out if you really want to. If you have an issue, please raise a PR or an issue on it, and we'll get around to fixing that. Hopefully there shouldn't be any. But the way that our guides are all set out is we have a directory structure that's the same throughout. So you can see this directory structure in my terminal here. We have a finish and a start directory. The nice thing about having both is that if, for example, you want to try out your application as it should be at the very end of the guide, then you can, and you can see what it should look like. If you just want to cheat and not do the guide, you can just use the finish directory, but I would suggest going from the start directory and going through the steps so you can actually get hands-on with the technology and learn for yourself. But finish is sort of where you can look if anything goes wrong and you want to compare if you've introduced a bug, or if you just want to know what it looks like at the end of the guide. But the one that we want to use in this particular demonstration is start, because that's really sort of that bare minimum of the project that's given to you that we then build upon through the steps throughout these guides. So that's what we're going to head into. We're just going to CD into that. And the first stage in this is, I'm just going to open that up in Visual Studio Code. Yep, you can see here that you can go straight into the start directory and try it into the finish, and try it out. But what we're going to do is we're just going to start and start. In this case, we're using Maven. In most of our guides, we do use Maven just to make it consistent, so you don't have to learn a new build tool with the different guides. But as I said, if you want to use something like Gradle or Ant, you can do. That's totally up to you. We know that Liberty is successfully up and running when we see this message, these stars, and Liberty is running in dev mode. That's when we know Liberty, sort of our server and our application are sort of up and ready to go, and dev mode is ready to wait to listen to any changes that we might make. The way we run tests is just by hitting enter. We made that a deliberate choice because we didn't want it to be really annoying in terms of running a test every time you make a single bit of change of code. So what we did is we wanted to make sure that it was a deliberate choice to actually run the tests within your server. So to run them, all you have to do is go back to your terminal and hit enter. So it's fairly straightforward and easy to do. You can see here I've got one test running and that has passed, which is great. So let's go ahead and take a look at our application in a bit more detail and actually start implementing microshed testing and test containers. We provide all of the code you need within the guide itself, within the browser in this case. So all you need to do is just open that up and copy and paste the code across. So here we go. You can see here I'm starting to add the annotations that I need in the imports. So I've got the at microshed test annotation and the at container annotation. The microshed test, I'm just going to pause it. The microshed annotation that we had at the very top, which you can see here on the right-hand side, what that really allows is that it indicates to the test class that we want to be using microshed testing for this. The person service IT class, which is what we're editing right now, it outlines some basic information that informs how microshed testing starts the application runtime and at which URL path the application is available. So that's sort of all included within that at container annotation block there. So now, obviously, because we've already utilized dev mode here, it's already picking up on these changes for us. So we should be able to see that now when we run the tests, what we're using a container to run those tests in. Yep. So there we see the message starting one container in parallel for the person service IT class. So fantastic. We're now utilizing test containers essentially already through microshed testing. But if you have a look at our test, it's not really doing much. It's just void. So what we really want to do is we want to introduce sort of more to our code to enable this test. So with microshed testing, it's important to note that applications are exercised in a black box fashion. So black box really means that tests can't access the application internals. So instead, the application is exercised from the outside, usually with a HTTP request. So to simplify the HTTP interactions, we're using a REST client to be able to inject into the tests. So this is essentially what we're enabling here. You can see I've highlighted here, we've got an import now for REST client, and we're utilizing the microprofile REST client annotation here, which you can see in my class. So this will allow us to be able to actually trigger those tests because of this black box style of testing. So I'm going to copy and paste that over and save. And again, because we're in dev mode, it's automatically picked up my changes. So that's sort of already happened. You can see here within my terminal that the test compilation was successful. So now when we run it, what we see is, as well as that message about the container, we now see this message about building a REST client for the class to be able to actually utilize our tests. Great. So that's now working. So now that the setup is complete, we can now actually write our first test case. We can actually test something. So we're going to start by testing this basic create a person use case for our REST-based application. So we're just checking we can make a person. In this case, he's called Hank and he's 42. So we're going to paste that in, save, obviously go back to our terminal and just check that our application is still working, our tests are still running, and they're still successful. So let's have a look here. We've still got that message about the container. We've still got that message about the, there's the REST client message. And then we also have the fact that that test ran successfully, which is great. However, that's just one test. Now, obviously, normally, we don't just want to test one unit test when it comes to testing our application, because normally there's more functionality than just that one individual test. So now what we want to do is enable further unit tests still within this same container environment to make it effective and efficient in terms of utilizing those resources effectively to test as much of our application as possible, utilizing those resources. So now we're adding a lot more tests here. So we're adding various different tests like can we test the minimum size of name, the minimum age, whether we can update someone's age, because obviously as we progress through years, we need to update their age. So in this, you can see we've got loads more tests using that test annotation from JUnits. So now when we run our tests in our terminal, what we should see is we've still got the container, we've still got the REST client, but this time we've got 6 tests and all of them have been successful. So we're being really effective in terms of utilizing the infrastructure. Now, the nice part is it's obviously understandable that sometimes you will need different container configuration for testing different parts of your application. So if you need that, you can actually go on to the second part of this guide, which looks at how we can set up 2 different containers and use those different container configurations to be able to test different parts of our application. So that's the next section of this guide. But just in the interest of time, I didn't have time to be able to actually run that for you in this demo. But hopefully a little teaser for you to try out the guide yourself, which I will show you in the next section. So that sort of takes us to the end of, we've gone through creating, we've gone through editing, we've gone through building, and we've gone through testing, and looked at various different tools and technologies from open source communities and projects that we can make use of to be more productive developers. We've looked at IDE extensions and plugins, starter projects, we've looked at test containers, and we've looked at things like code generators as well. So hopefully there's something in here that has sparked your interest and something perhaps you're not already making use of that you can make use of in your application to be able to be more productive and effective and making it cloud native applications in Java. So as I mentioned, we are developers. We like to try stuff out ourselves. So if you do want to try this out yourself, then please do go ahead and check out our guides. So we have, I think it's literally over like 56. If any of the microprofile or Jakarta EE specifications take your interest and you want to try them out, we usually do have a guide on each of those APIs that acts as sort of an introductory guide. So check those out as well, or you can check out the guides that I showed within this presentation. As I mentioned, you can do them locally like I did for that last test containers guide, or you can use our cloud native environment. So for a lot of people, often it can be difficult to be able to have prerequisites on your local machine if your machine is locked down, for example, due to security vulnerabilities or risks. So in this case, what you can do is utilize the cloud native environment we've developed. All you'll need for this is a browser. That's it. Preferably Chrome or Firefox, but hopefully we'll have at least one of those. And in this, basically, it removes the need to have any of those prerequisites down on your local machine. What it is it's based loosely off sort of the Thea IDE. It looks very similar to, say, IntelliJ or VS Code. So you'll hopefully be familiar with the layout of this. You'll have the instructions on the left-hand side, the IDE on the right-hand side, and normally a terminal on the bottom right. If the terminal isn't there already, you can just about see in the top menu here, I've got Go Debug Terminal Help. Just click Terminal, New Terminal, and it will appear. The nice thing with this is that actually it's really easy to copy and paste over the code we've already provided rather than having to switch back to the browser every time, because it's literally in the same window. We have 2 different buttons. This is a bit of an older screenshot. We've got 2 buttons now in this particular environment. One is a copy button, so you can just click the copy button and then go over to the terminal and paste for the commands. Or we also have an automatic execute button that does that all for you. So it really is super easy to get started with this with very minimal sort of blocks, hopefully, in place. So you should be able to get started with this straight away and have a go with some of the sort of technologies and the tools that I've shown throughout this presentation. If you want a deeper dive, most of these labs are like 20 to 25 minutes long in length, so it shouldn't take too much time. But if you really want to go deep into how do I go from nothing all the way through to a sort of an enterprise grade application with security and REST clients and all of that fun stuff, then check out the deep dive link that I've included in this tab here, which is about a 2-hour lab. So it does take some time, but it will literally take you from end to end, from start to finish. So that's a great resource to be able to make use of. So hopefully, in summary, I've at least shown you one tool that you can make use of. I've tried to create this slide to sort of show the various different tools that we took a look at, where they fit in terms of what do they work with. Is it MicroProfile? Is it Jakarta EE? Or is it a specific runtime technology or feature that you can make use of? So hopefully you guys can go away and evaluate, okay, which tools could I maybe use to be more productive in making cloud native applications, and try it out for yourself. As I promised, here are some of the resource links. So if you're interested in, for example, some of the Liberty tools, or the starter projects, or the extensions, then they're available here. The bottom link, that's the extension for the for MicroProfile, for VS Code. And then I've also got some generic links here for our guides relating specifically to Jakarta EE, or to MicroProfile, or that deep dive that I mentioned as well, and a link to find out more about test containers if you've not come across that before. So with that, I'm going to say thank you very much for listening and for being here today, and I'll get round to answering questions.
Thank you so much, Grace, for your presentation today. And yes, we do have a couple of questions in the chat already. So we have 2 little questions here. The first question is from Andrew. So can Open Liberty support remote EJB transactions inbound, outbound, required support and mandatory annotation?
Yes, so we can. The nice thing about Liberty is that, so if you're not familiar with Liberty already, essentially the history of it is that you might be familiar with something called WebSphere. Many people are, not always necessarily positive, which is a shame. But it was really because WebSphere was kind of bulky and kind of quite heavy in terms of being able to be agile in development. And so in 2014, we essentially took that feedback on board and created Liberty to be a really modular, lightweight runtime, loosely based off what we offered in WebSphere. And then in 2017, we open sourced that to create Open Liberty. So a lot of the features and the functionality that you originally would have had in WebSphere, for example, are still available in Liberty and Open Liberty. And the nice thing is that because we have that history of supporting enterprise clients in WebSphere, we have the understanding that we need to cater for both enterprise, more historical applications, as well as the brand new cloud native serverless applications. So actually we have quite a range of architecture support within Liberty, which does include being able to support things like remote EJBs. So I would definitely suggest checking out Liberty in a bit more detail, especially if you're on that modernization journey, because we can really enable that transition and support that breadth of architecture styles. Hopefully that answers your question.
That's great. And we have another one from Buddy. It's, does it support MQTT? If yes, can you show an example PF command?
It does support MQTT. We support a lot of different messaging frameworks. So for example, we also support things like Kafka. We also support things like IBM MQ, for example. So it depends on which one you'd want to take a look at, but we have guides for that. So if you go to the website, the Open Liberty website /guides, we've got like a Kafka guide, for example, and we have like a whole messaging section that you can take a look at. So you should be able to try it out and have a look at it there.
Okay, great.
Cool.
Antonio is asking, if possible, can you share the slide deck as well?
Of course, yeah. I will be sharing that. I'll email it over to you guys, and then maybe you could add it to the Crowdcast webpage. Otherwise, if you want to follow me on Twitter, I'll also post the link on Twitter. My handle is up on the screen here. It's @GraceJansen27. I usually share. I'm trying out slide deck, but if that doesn't work, then I'll do slide share as per usual. It'll be online somewhere, basically. So I'll share it there. And what was the other thing? Oh, URL for the labs. Yes. Which labs, Antonio, which labs were you interested in? The guides? Or was it the deep dive? This is the link for the guides. Let me grab the one for the deep dive. Grab that for you here.
That's perfect. Well, while you're doing that, it doesn't look like there's any other questions. So we are also looking to book more Jakarta Tech Talks through 2023. So if you're interested in presenting, feel free to fill out the form that I'm going to link in the chat as well. And finally, if you have any feedback on the Tech Talk program, we would love to hear from you. So just click on the green button that will pop up once we close the webinar, and let us know how you enjoyed the talk. So thank you again so much, Grace. Thank you, everybody, for taking the time to joining us today. And we hope that you all have a wonderful morning, afternoon, or evening, wherever you are in the world.
Thanks for having me.
Thank you, everyone.
It's great to join.
See you. Bye.